So one of the things that we're covering for today, like I said, we're doing a double lesson today, but the first part that we're going to cover for today is called slope-intercept form. So you guys already know how to find the slope. Remember, slope is our rise over our run. If you have 2 points and you're having to find slope, then it's this difference of the two y's over the difference of the two x's. So basically y2 minus y1 over x2 minus x1. If it's in the table format, you're looking at how the y changes over how the x changes. So all those different things to find your slope. Then you're going to have what's called slope-intercept form. And the intercept form is where your graph or your equation itself eventually crosses over the y-axis. The point that you're crossing over the y-axis is considered to be your intercept that we're focusing on. So for here, all intents and purposes, I will always be presenting to you your slope using the green. And the value m, so y equals mx plus b, m stands for your slope. M is going to stand for your slope. When we see plus b, it could also say minus b. If your intercept happened to be a negative intercept, so if you're crossing over the axis at the negative values, there's my black. It could say minus instead of plus. So it's plus or minus b, depending on whether b is positive or negative. But that's the point at you crossing the y-intercept, where x is equal to 0. So write that down. X is equal to 0. Okay, that's really important for you to understand. At what point does y equal a value when x is equal to 0? Sometimes it might be 0, 0. If it happens to be a proportional relationship, we know if it crosses through the origin, then that would be proportional. That would be your y-intercept being 0, which is why we have that format of y equals kx, k being your slope as well, or your constant of proportionality. But if it happens to cross over a point that is not the origin, then that's when you have a plus or minus b value. So in this case here, for the little example we've got, the point that we're crossing over the y-axis is at the value of 2. So our value b is going to be equal to 2. So we have a plus 2 here. And then our slope happens to be going up 3 to the right 2, and up 3 to the right 2. And it's moving in a positive direction. So there's our slope of positive 3 over 2. So we put that in for our m value. And that gives us our equation, y equals mx plus b. Y equals 3 halves x plus 2. Okay, so you're identifying slope, and you're also identifying y-intercepts. Y-intercepts are very easy to identify when it comes to a graph because you're just looking for the point that you're crossing that y-axis. Okay, so let's take a look here. We're going to start off real simple first. Given the equations, we're going to identify what our slope is and what our y-intercept is. So if we're looking at the very first problem, y is equal to negative 5x plus 3. Remember, the slope is the value that is attached, the coefficient to the x. So that means our slope is equal to negative 5. And then our y-intercept is whatever you are adding or subtracting in the problem. So in this case, we're adding 3. So my y-intercept is at 3, or otherwise known as 0, 3. Sometimes they might present it to you as just the number, where that is the intercept value. Sometimes they might present it to you as a point, okay, a graph point, an ordered pair, where x is equal to 0 and y would be equal to 3. Okay, so let's go through this real quickly. Who can tell me what is my slope for problem B? Raise your hand. Tell me, what is the slope for problem B, Jamez? 1/4. Our slope for problem B is just that 1/4. What about our y-intercept? What is our y-intercept going to be, Cole? So negative 6. Okay, if I were to write it as an ordered pair, it'd be 0, negative 6. Okay, what about for problem C? What is my slope for problem C? What is my slope for problem C? Matthew? Negative 1. Not the x. We don't include the x. X is not part of your slope. Just the negative 1. Just the negative 1. Okay, and then the y-intercept. What is the y-intercept going to be in this case? Eker?
5 5 or 0, 5.
5 or 0, 5. Good. All right. So it's really easy to identify your slopes and your y-intercepts from an equation. But of course, you're not always going to be doing that. Sometimes you're going to be given the slopes and the y-intercepts, and you have to form your equation. Or you're given a graph, and you have to form the equation. The equation is always going to be y equals your m value times x plus or minus your b value. Okay, so if we're taking a look at problem A, where we're having to write the equation, they, nicely enough, have already given us the slope, and they have already given us the y-intercept. We just have to substitute it back into that formula. So again, y is equal to mx, and then plus or minus b. So we already know what m is going to be equal to. Remember, this is our m. That's a positive 2. We already know what the b value is going to be equal to. That's a negative 8. So then we just fill in the rest of the formula. Y equals 2 times x minus 8. And there's our equation. Okay? Now again, that was the easy one. They told me, hey, this is your slope, this is your y-intercept. Put it as a slope-intercept form. Sometimes you have to actually solve for it yourself by finding it on a graph. The easiest thing to find first always is your y-intercept. It's always the easiest thing to look for first, because it's, again, where you cross your y-axis. Who can tell me what value is my y-intercept from this graph? Somebody besides Eker. Elijah, you spoke up. So, all right, Elijah, looking at this graph, what point does the line cross the y-axis? Come on, honey. Look at your graph. At what point does the line cross the y-axis? 20. That's it. Yeah, you can pretend you are. All right. So this is our b value. Our b value is going to be equal to a positive 20. Now for the slope. The slope is going to tell us how far up and to the right, in this case, are we moving from one point to the next. And they already gave us 2 points. We have the y-intercept, and we have this next point that was graphed on here. So we're having to look and see how far up and how far to the right. Now remember, are you counting boxes or are you looking at the intervals? Intervals. You're looking at the intervals. So how far up are we actually moving? By 5. We're moving up by 5. How far to the right are we moving? By 1. So our slope is going to be a positive 5 over a positive 1, which is just a positive 5. Okay, now we can go ahead and put it in slope-intercept form. It's y equals 5 times x plus 20. 5 times x plus 20. Okay, go ahead and do number C, or not number C, but problem C on your own, quickly. Not number C, problem C. All right. Who can tell me what the equation is going to be? Caleb?
Y equals negative 1 times x plus 3.
Very good. Y equals negative 1 x plus 3. Now, do I have to write negative 1? No. I don't have to write the 1. I could just write y is equal to negative and then x plus 3. Okay, that 1, remember that invisible math. You don't have to write the 1 for a coefficient. If it's a positive 1, you don't have to write it. If it's a negative 1, you just have to write the negative and not the 1. Okay, this is the more common form that you're going to see it written in. All right, I do want you to try one more, because there is going to be situations where it's not just a graph and it's not just information given to you. They might tell you a table of information where they're going, hey, this is our x, this is our y's. So when x is 2, y is 13. When x is 3, y is 16. When x is 4, y is 19. And when x is 5, y is 22. And I want to know, what is the slope-intercept form? So in this case right now, I don't see a y-intercept, because do you see a value where x is equal to 0? No, but can we eventually get to that? Yes. So first thing we're going to do is we're going to see, how does our graph change? So for our y's, what are we doing consistently here? You're adding 3. Good job, guys. And then what about for our x's? We are adding 1, plus 1 every single time. So I know that my slope, m, is going to be 3 over 1, or just 3. Now I can work backwards to get where x will equal 0. So if I want to work backwards, instead I'm going to subtract 1 and subtract a 3. And that's going to take me to the value, what? 110. Good, that would take me to a 110. Am I at my am I at my intercept yet? No, I got to keep going. So I can subtract a 1 and subtract a 3, and that's going to take me to 0, 7. There is my slope-intercept form. Okay, or not my slope-intercept form. There is my y-intercept when x is equal to 0. So you can keep working your way backwards until you get where x is equal to 0. So my b value is going to be at a positive 7. Okay, now we can plug it into our formula. Y is equal to 3x plus 7. Okay, any questions? All right, let's go ahead and flip it on over to the back side. Yeah, the back of that page. All right, so for here, you have some word problems in which you're going to have to graph the slope-intercept form. So finding slope-intercept form is easy. Graphing slope-intercept form is just as easy. So we have a kayak rental pavilion that charges $15 per hour and a $2.50 fee for a brief lesson on kayak safety. So the total cost to rent the kayak is going to be by this equation. Y is equal to 15x plus 2.5. Okay, remember that 2.5, that $2.50 only happens once. You have to do the safety lesson one time, and then you're free to go. But for however many hours that you're going to have the kayak for, that's the event that is happening multiple times. That's why it's your coefficient. So we want to graph this equation using the slope-intercept form, and then we're going to interpret what the slope and the y-intercept are going to represent. So when we're doing such a thing, the first thing that we want to do, so we'll say step 1, whenever you are given a slope-intercept form equation, the first thing you always have to do is you have to graph a point. You have to graph a point first, and they give you a point to graph. They give you the y-intercept. So you're always going to start off by graphing the y-intercept. So in this case, our y-intercept happens to be at 0 and then 2.5. So looking over here at my graph, I'm going to have to go ahead and create some values here. I'm going to go ahead and count each of these by 1. So 1, 2, 3, 4, 5, 6, 7. It keeps going on up to, I think, 14. Okay, and then for here, we're going to count by 5s. So each of these will count as 5, 10, 15, 20, 25, 30, 35 and 40, 45, 50, 55, 60, 65, 70. Okay? So graphing my y-intercept at 0 for x, I'm at 2.5. So that means I'm going to be halfway between the 0 and the 5. Okay, halfway there. Okay, from there, we can move on to step 2. Step 2, we're going to use the slope as directions. Remember, we talked about directions, that if it's a positive slope, it goes up and to the right or down and to the left. If it's a negative slope, it goes up, left, or down, right. So it has the opposite signs, okay? So in this case, my slope happens to be 15 over 1, right? It's 15. We write it as a fraction, 15 over 1. So based off of how I'm having to graph it, I can only go up and to the right. I can't go down and left. Okay, the graph itself won't let me do that. So I'm going to go up 15, and then I'm going to go to the right 1. So from here, if I go up 15, what's 2.5 plus 15? 17.5. So we're going to go to 17.5, and then to the right 1. Okay, then we're going to do that again. And that's going to take us to 32.5 to the right 1. Okay, once you've graphed a couple of those points, you can then go ahead and connect it to form a straight line. Now I know you guys are, you guys sometimes don't like to use rulers or a straight edge, but you're going to want to in these cases. You want to make sure that when you are graphing, and the nice thing is when you're doing this digitally, it will have a graphing tool for you that you can use a nice straight line to connect everything. You won't have to worry about drawing it straight. It will automatically give it to you straight. But you want to make sure that you guys use a ruler. If you don't have a ruler, you can borrow one later if you need it. You can borrow one. I always have available. Okay? Now, we need to interpret what the slope means. So remember, the slope is 15. What did the slope represent? If the slope is 15, it's 15 what?
15
$15 per hour, right?
15 hours.
15 hours. Slope is going to equal $15 per hour to rent the kayak. Okay, and then what did the y-intercept represent? The y-intercept was at $2.50. What did that represent again?
The brief lesson.
The lesson. $2.50 for the brief lesson. Okay, so you are trying to identify those things. What does it represent? What does it stand for? Okay. I'm going to go ahead and skip problem 4 just for the time being. You're going to do problem 4 on your own. I would like to go to problem 5 real quickly, so that way you guys can try problem 4 and 6 on your own. So let's move down to problem 5 real quick. For problem 5, again, trying to identify what the slope-intercept form is going to be, you first need to identify your slope. So let's find the slope. We're going from -2 to +10, and then from 10 to 22, and 22 to 34. What are we doing? Plus 12, right? We are adding 12 each of these times, and I will zoom in on this so it's easier for you to see. There you go. All right, what about for the x's? We're going from -2 to 1, 1 to 4, 4 to 7. What are we doing? Plus 3, +3. Good, we're adding 3 each time. So for my slope is going to be a +12 over a +3. That can simplify to what? 12 over 3 simplifies to 4. Okay, so my slope is 4. All right, y-intercept, they don't have one written here, do they? In fact, there's no way that we can technically go, you know, we can't be like, oh, I'm just going to subtract 3 and subtract 12. Well, no, that's going to take us further away from 0. Well, I can't just add 3 and add 12 because then that just takes us up to here. So what you need to do is focus on what the slope was. What was the slope? It was 4, right? Isn't that technically 4 over 1? Mm-hmm. So can't I go backwards 4 over 1 from each of these? That being my x and that being my y. I could go backwards 1 and backwards 4, can't I? I can go backwards 1 and backwards 4, and that will take me to 0. And what's 10 minus 4? 6. So I can have 0, 6 as my y-intercept, my b value. Okay, there's also another way that you could do that. You could just pick one of the points and plug it into the y equals mx plus b, and then just solve for b. Because if you pick one of these points, you've got a y, you've got an x, and you've got your slope, don't you? Let me show you what I mean. You could pick a point. In fact, I'm just going to do it on a separate sheet of paper real quick. If you're confused about how to work backwards, you could instead pick a point, and you could go, okay, y is equal to mx plus b. If I pick the point 110, I'm going to pick the point 110. So 1 being my x and 10 being my y. And then I also just solved for m. My m was 4. So I'm trying to figure out what b is going to be. So I have my y equals my slope times my x plus b. What's slope times my x? What's 4 times 1? 4. So now I have 10 is equal to 4 plus b. I can work backwards by subtracting 4 from both sides, and I'd get 6 is equal to b. You could do that as well. You can choose any one of these points for x and y and plug it into the formula along with the slope that you solved for, and then solve for b. Those are two methods that you can use. It's up to you. You choose which method you want to do. Okay? A lot of people find that this is easier because then they don't have to think, which value of slope do I need to use to be able to subtract it? Because sometimes even your slope in simplest form is not going to get you to the 0. Okay? All right. Let's take a look. We're going to write in our equation. Y is equal to m times x and then plus 6. All right, I want you guys to do number 4 and number 6 on your own, please. Problems 4 and 6 on your own. Let's take a look here. So for problem 4, you should have gotten the graph to look like this. You have a y-intercept at 3.5, and then it's going to constantly be increasing by 0.5 or 1, going up 1 to the right 2. So we go up 1 whole value to the right 2, go up 1 whole value to the right 2, and so on and so forth. Yours might look a little bit differently depending on how you did your intervals, okay? Your slope represents the 50 cents per mile of travel, or it's $1 for every 2 miles that you are traveling. And then your y-intercept is $3.50. That's an initial cost. So if we're thinking of this as like maybe a taxi, it's a taxi fare, when you get into a taxi, you have a flat fee that you pay up front, the $3.50 or $5 or whatever it is for them just to get there, and then they charge you how much it takes, per mile that they're traveling. All right, for problem 6, your slope was 3 over 4 because you're constantly increasing by 6 and increasing by 8, so 6 over 8 is a 3 over 4. And then my b value is -2 because if I take this 3 over 4 and work it backwards, that means I'm subtracting 4 from the x and subtracting 3 from the y. That takes me to my slope, or to my y-intercept, 0, -2. So I have -2 as my y-intercept. So y equals 3/4 x minus 2. Okay? Any questions? No. All right, let's move on to the next. We're probably not going to do every single one of these problems because I think it's pretty, once you start doing a couple of them, you get the gist and it's pretty easy. So we might just do like a couple of them. Huh? But now you're going to do well on it, right? Because you should understand it now. All right, again, as we're talking through this, reminders for your slope-intercept form, you first have to plot your y-intercept, which is your b value, and then you use your slope for direction. So looking here, we have 1/2 x plus the 3. That means that the first thing that we're going to do is graph the point 0, 3. So looking at this graph, we're going to go 0, 3. There's our first point. Then we're going to use our slope. Our slope does have direction. Now, this is where we can go forwards and backwards. So since our slope is a 1 over 2, that means that they both could be positive, which means that we could go up 1 and to the right 2, or we can write positive slopes as double negatives. So they both could be negative. So -1 over -2, which means we would be going down and then to the right, to the left 2. Okay, those are opposite directions, but they're going to still align up. If you're graphing and it's not creating a straight line, did you do it correctly? No. Okay, so let's take a look first. We're going to go up 1 to the right 2. That would plot us at the point, at positive 4 and then, or sorry, positive 2, positive 4. Then again, I can do it again. Up 1 to the right 2. And I could keep going until I run out of room to graph. Okay, and then I can go in the opposite direction. So now I could go down 1 and to the left 2, and I can keep doing that until I run out of room on my graph. Okay, and I've just created my line. Okay, let's take a look at the second problem. We have negative 3x plus 5. So again, first thing we're going to do is plot our y-intercept. What's our y-intercept here? 5. So as a point, it's 0, 5. So we're going to start at 0, go up 5, 1, 2, 3, 4, 5. So here's 0, 5. Now my slope is negative 3. My slope is negative 3. It needs to be written as a fraction. So what's the fraction going to be? Negative 3 over 1. So we can write it as negative 3 over 1, or we could write it as positive 3 over negative 1. Either one of those would be fine. They both come out to a negative slope. If we do negative 3 over positive 1, then that means our directions are down and then to the right. If we put positive 3 over negative 1, that means we're going to go up, but then we're going to go to the left. Again, you can use both. Let's start with down and to the right. Down 3, 1, 2, 3, to the right 1. Down 3, 1, 2, 3, to the right 1. Down 3, 1, 2, 3, to the right 1. And you can keep doing that until you run out of room. 1, 2, 3, to the right 1. 1, 2, 3, to the right 1. Okay? You could then go the opposite. You could go up 3, but then to the left. Again, you're trying to create a negative slope, so it should look like a negative graph. So if we go up 3, 1, 2, 3, to the left 1, and then up 3, to the left 1. And then there's your graph. Again, if you're going to connect them, be very careful how you connect, because you want to make sure it still stays a straight line. Okay, I want you guys to try the bottom two, the y equals 2x minus 4 and the y equals negative 2/3 x minus 1. I want you guys to try both of those on your own. Do both of them on your own, yeah. So let's take a look. Y equals 2x minus 4. You have a slope-intercept of, you have an intercept of negative 4 and a slope of either positive 2 over positive 1, which means up and right, or negative 2 over negative 1, which is down and left. So this is what your graph should look like. Okay, check and see, look at some of your points, make sure that you've got the same graphed points. You don't have to have all of them.
You have to do the whole thing.
Like I just said, you don't have to do all of them. I showed all of what they would progressive to, to look like. Okay? Now let's take a look at this next graph. For the next graph, we've got negative 2/3 x minus 1. So our slope, our intercept is negative 1. Our slope is negative 2 over a positive 3, which means down and to the right, or positive 2 over negative 3, which would be up and to the left. So having your graph here at 0, negative 1, and then these are the progressive points that could be plotted. So you want to make sure that you've got those plotted down. You don't have to have all of them. Yeah. So you did the wrong direction. Caleb. Stop. All right. Let me see. No, that's a positive slope. That would be positive slope. You got to go in the different direction. It's negative slope. Okay. All right. We're gonna skip the middle page. Skip the middle page. We're going to go to the last page. Let's go to the last page. What I want you guys to do here, you are going to identify the slope-intercept form. You are going to identify the slope-intercept form for these two graphs. Then you're going to do it for these three tables. And then you're going to do it for these 2 point sets. I want you to do this whole back page. Whole back page. I do want to make it a little bit faster. So just do this one. Just do this first one. Just do these first 2 tables. But I do want you to do both the point sets on the bottom. Okay? So we're going to scratch this one off. Don't worry about this one. Don't worry about this one. All right? Okay, taking a look here. For the very first table or the very first graph, you should have found that your slope is going to be a -2/1 and that your y-intercept is at -6. So you'd get the equation y is equal to -2x minus 6. Okay. For your first table, you have a slope. Notice that you had a bunch of +6s over +3s, but then at the very last one, it goes +10 over +5. It still simplifies the same thing to 2. So you have a slope of 2 and a y-intercept that was given to you already as 0, 2, which was 2. So there's your equation, y is equal to 2x plus 2. Huh?
14 plus 3 is not 10.
Oh, sorry. That's still 8 over 3. I'm sorry, 8 over 4. 8 over 4, my bad. Still simplifies the same thing. It's still 2. You still have a slope of 2. 2x plus 2. All right, here, for this one, we're increasing by 3 each time, increasing by 2 each time. It's all going to come out to the same thing of 3 over 2. If you work backwards, you get 0, 2 for your intercept. So you have 3/2 x plus 2 for your formula. All right, for this last part, finding the slope, you have to do the difference of your y's over the difference of your x's. So 4 minus 2 over 1 minus 0. Shh. You get 2 over 1. Guys, hush. You get 2 over 1 or just 2. Your intercept was already given, and one of the points that was given to you guys was the intercept. So that's the nice thing right there. It's already been provided for you, so you have 2x plus 2. For your last one, though, the intercept is not given to you. So when I show you your slope, you do 18 minus 8 and -1 minus 3. Okay, 18 minus 8 is 10, -1 minus 3 is -4. You get -5 over 2 as your slope, but those are not going to work to get you backwards to a point. That means that you're going to get a decimal value for your intercept, and that's fine. That's when you are going to need to use one of these points to substitute back in. So we're going to use this point as my x and my y, and I'm going to substitute it back in into the formula. Y equals mx plus b. Y was an 8. My m was a -5 over 2, and my x is a +3. And then we have plus b. So I'm going to get 8 is equal to -15 over 2 plus b. When I solve, I'm going to find out that b is going to wind up being equal to 31 over 2. When I solve that, I'm going to get b is equal to 31 over 2. So then in my formula, I have b equaling 31 over 2. Y is going to be equal to -5/2 x plus 31 over 2. You will not have them as difficult as this. You will not have them as difficult as that one, okay? You do have a quizzes. A quizzes. You have one attempt and one attempt only. Get on right now.